M2M, so it's not machine-to-machine communication. If you want to hear about that, maybe you need another talk. Today is about model-to-model transformation. But where's the problem?
Just no problem.
Everything good? Okay. Yeah. So then behind the talk, the idea behind our model approach is that we have a big legacy model with a lot of information. And we really tried to cut it down and to make it smaller, but it has grown over some years, several years. And even if we try to remove some information, this functionality broke, and we thought, maybe because it need to be calculated afterwards. But on the other hand, having a big model with all information in it, which is generic, has some tremendous benefits also on the other side. So we thought about how can we combine these two things, having a very specific model, but also following a generic approach. And this is where we started to think about a round-trip structure. Okay, why did we did what we did and how? Then there should be a small sample and a small outlook also. Okay, why? What we have is a legacy main model which has all information. This is the biggest benefit of this model, and it's also somehow the downside because it's big and it's slow. This means it's also limited in some cases. For example, if everyone listens to such a big model, then the whole system slows down. So maybe you're also not allowed to use data binding anymore on a really big EMF model. So we thought this can't be the case, this is not really good. So we came up with the idea of a domain model, which of course shall be fast and small. And this only can be achieved if we have there only the required information. So we have state-of-the-art technique. If we have a smaller EMF model, we can use EMF projects more or less out of the box because we have a structure which might apply for this project. We can use data binding again, which slows down development time, which reduces errors, which enables proper development. And what you need to decide between is, on the one hand, there's the development time, on the other hand, the learning curve. So we get faster because we can use, for example, projects like Sirius, and we have a graphical editor. But also the people need to learn how to use the framework and how to use these different projects.
Can I ask a question?
Yeah, of course.
What type of models were you talking about? Is it data models? Or I'm completely lost because I came for the machine-to-machine. But
okay.
I would like to listen, but I would like to understand the context of what type of models.
Yeah. Okay.
Models
So what we have here is actually it's data models. It's EMF is Eclipse modeling framework. It's created to have good data structures, but you also have a lot of projects which are built on that. So they are enabled to show this data, to display it, to manipulate it. So one very big benefit of EMF is that you have commands, for example, out of the box, that you have an Eclipse integration which works perfectly from the beginning actually. So you have undo, you have redo, you have all these functionalities which you really require, but which can be a pain to implement. So, and you don't have to do it because you have this framework. And in this framework, you have also some graphical editors to create your model. Actually, it's like an UML to a Java round-trip machine. Okay. So, what the idea is, we need this round trip also here from EMF to EMF, but in this case from the legacy main model to our domain model. Okay. How can this be achieved? And there was the idea, of course you have the source, we have a target, so our domain model, and in between there must be some transport layer. That's actually clear. So if we have a look at the transport layer, and we have of course the model, but if you have a look at the transport layer, then it would be cool if it's somehow generic. So the idea was, hey, we have one transport class which handles the transport. It cares about import and it cares about the export class. Export needs to know the import because it somehow needs to know where to put the data back, so they need to be linked somehow. And of course we want to be generic, but on the other hand we also need to be type specific because different elements might be transferred, also transported in a different way. So that's where the type specific part downstairs comes up. So you have a type specific importer and a type specific exporter, and these two again are in a type specific transporter again. So this should somehow show the idea of that we are class specific. If you know EMF, then you know there are the E classes, so actually these are classes, but we are also able handling the superclasses. So this means if you have a named element which all elements are derived from, then you can implement the importer for that class and it will handle also the inherited classes. So this is the basic idea. Okay, if you have a transport, then we have import and export. So how can such an import look like? What we decided to do is using 3 model instances. Oops. So there we have some fancy names. It's soil, current, and origin. So we have the external data. The external data directly gets into current. So this is what's currently outside our model. This is what we are loading. So we are not loading only from an EMF model, but we also can load from a problems log entry. We also can load from the file system, for example. So, and this all is gathered up into one model in the end. And first is loaded into current, and then we have origin. This means what we had originally. This is a copy of this model instance. And we have soil. This is what the farmer is working on. So this is what we are in the editor are working with.
So origin is the backup of current, basically.
Kind of. If you have the editor, if you have, for example, an editor and you're using the system, then it might happen that someone changes something outside your editor, for example, in an Eclipse editor. And then you find out what is actually different now. If you just change origin, in this case, then you might not find out that you do not have to delete things which are not in soil in the export step. So you need somehow to know that what was originally there, what was created outside, and what was changed by the user.
One additional question, so are we talking about the domain-specific smaller model here, or is current the large legacy model and soil the domain?
So these are 3 instances of the domain model. And what is here the legacy main model, that's the external data.
Okay.
Okay, and of course we use data binding for the UI because we can. And now we change the data, and this change was done to soil. And some fancy thing we need to do now is using EMF compare out of the box. So this was really fun to do because we just used EMF compare, used it like it is, compared these 3 models. We had proper identifiers on each element, so we can compare them very well, and we get a comparison with all differences. And these differences afterwards need to be exported. Okay, but maybe we'll come to a small sample. So how will this look like? A domain model, as we talked about that, this is a very simple one. We have a file, we have element. An element can also have elements, so these are child elements. And the importer would iterate over the domain model and over its references. So this part needs to be generic because there could be a lot of different domain models, and this approach seemed to be working for every model we considered. So we iterate over the references. which means if we come to the file, then there will be a file type specific importer. It's found because of a reference to file, which is here from root to file, so this is not shown in the model. And if you go from root to file, then we ask this importer, hey, find the file, fill the attributes, and then fill the references. So here comes the recursive part. Now, the file type specific importer asks, again, the importer above, which knows about all type specific importers, hey, how do I have to fill this reference? And this, in this case, it's for elements. So it asks the type specific, the element type specific importer. And again, here comes the generic part. It finds the element, it fills the attributes, and it also wants to fill its references. In this case, again, we have a referent from element to elements. So it again asks the importer, hey, which type-specific importer shall I use? Oh, you can use again the element type-specific importer, and then it re-imports it using this type-specific importer. Some nice thing which we need to do and which is beneficial is that we have a cache inside each type-specific importer. So if you know, for example, only my file system changed, then you wipe only the cache of the file type-specific importer, so you only reload this part. And this, of course, makes it a bit faster. Okay, now we have a domain model instance. We have loaded data inside of it from nodes. And again, we have, of course, 3 instances: current, origin, and soil. So that's our naming. Of course, there might be better names. Hey. What happened now is someone edited in the editor, for example, and it changed soil. So we have here a change. And now we can compare these 3 model instances and find out with EMF compare that element A1 is different. So we have information about the difference. We know what has changed from what to what. This all EMF compare provides. So we do a save. And how do we save elements? In this case, again, there comes the element type specific exporter, and it cares about the change. It first checks, hey, is this main model node, is it already there? If not, then it creates it, and it also adapts the changes to the main model. And it adapts this to the node. Okay. Are there questions regarding that one? Then I would just go to the next point. And this is also, if you are new to EMF, remember e-annotations. They can be really beneficial for your work. So what you can do with that is you can place some information in your model. And these informations are not replicated. They are there for this E-class, for this single, for example, for file, you have additional information that file ends always with .txt. And this information you can put into an e-annotation. And your importer, in this case, for example, can then check, hey, is there an annotation on this class? Which tells me which elements to filter for. For example, which files should I import? Only the .txt files, for example. And you see, you can now use the same importer for a various type of files. That you say, I have a .txt file importer and a .html file importer, but you only will change the e-annotation. So they can really boost the productivity because you only will change your model, but you internally change your complete editor. Okay. So we had the sample now. Of course, I kind of have to prove that it also works in real life. So there we have a little more complex model, but it's not really complex. So what do we have here? As a project. The project has files. the files have modules, which are root elements, and the elements again have children. And the project has also all modules. These are also here referenced. And so we talked about this annotation, so they are also used here. So for the children, I just said, hey, use all children which are there. You also, so for my implementation, it's possible to search for specific parameters or to follow a specific naming pattern, or even to follow a path through the model and say, hey, I want from this element and go to some other element and use its parameter. So I don't know if you know AutoSAR, but the parameters are very like spread somewhere, and you might need some information which is placed in various locations also, and this is a way to combine this to get this together and to get a model which is more talking the language of the developer and not talking the language of independent OSI layers. Okay, and all elements are derived from named element, which has a name and an identifier, and also this has an annotation which says how this element needs to be filled. First close it. So and here also we can see now these elements are filled. We can add one other can, the we can. Of course, yes, we can. And it's added, as you can see, to the comp-stack ECC values RXML file. And there it is. I also can remove it. And of course, save it. And then it disappears. So the round trip is working. Here you can see there's a factory which it generates the transporter. So in the transporter, we have this autonomous transporter, which is the root class for this functionality. We add type-specific transporters. So one for the project, one for file, and one for BDOM elements. BDOM, that's our legacy main model. So legacy main model elements type-specific importer was a bit too long, so shortened it a bit. And if we remove now parts of this importer, then also if we open up the editor, of course, there's less to see. And so this enables you to have a very independent structure. So also if you're working with multiple developers, the different developers can care for their part. If we now add BDOM, the elements, then again, of course, no files are there. So if I open it now, I see that the project is still empty, but that the elements, they are there, but they don't know about about files. So this information is still missing. So in the last step, again, we have everything there. So safety. So now everything is there again, and now also the information about the elements is there. Okay. So why did we that? We wanted to be faster. We want to have a small model which is talking our language, and we wanted to be able to use standard EMF models, standard EMF projects. So what could be next? What we started to use is JavaFX, but this is not really related to EMF. What's more related is a data binding. So this we can use now again, and this is really beneficial, and it really helps to keep your UI clean and to be fast, because you do not like reload everything or something like that, which is really weird and not nice. We can use series. We can use EMF forms. So EMF forms like directly generates your whole UI. Series helps you to have a graphical editor, same as graffiti. And the idea behind this is having a toolbox for editor creation, because actually we need many of them. So we wanted to boost this development to be really fast. This is what we talked about. And of course, I have to tell you that you have to elevate this. And I really want to thank you for your participants.
So there are time for questions. So are there any questions?
Can you also do validation on model? For example, you have to use specific pattern for the name. If somebody yes, we can, then should be 1, 2, 3.
Yeah, so this is possible, and this is the point about state-of-the-art or standard EMF models, because for EMF there's the framework EMF validations, and this helps you to create such validations.
And like with framework is delivered.
Yeah, this is already there, so you can reuse it and don't have to implement it yourself. Any further questions? Okay, then thank you very much.